We have this integration problem which looks easy, but is actually quite tricky to solve. The first thing we need to do is to perform partial fraction decomposition. Note that the denominator has a linear factor, x minus 1, which we can represent in the form a over x minus 1. Then we have the irreducible quadratic factor, x squared plus 4. Here, remember the key rule for partial fractions. Degree of the numerator always needs to be 1 less than that of the denominator. So in this case, since the degree of the denominator is 2, its numerator will have a degree of 1, with the form bx plus c. Now, multiplying both sides by this denominator, we get the equation x plus 4 equals to a x squared plus 4 plus bx plus c times x minus 1. Now, expanding the right-hand side and grouping all the like terms, we get the equation x plus 4 equals to a plus bx squared plus c minus bx plus 4a minus c. Then, comparing the coefficients on both sides, we observe that since there is no x squared term on the left, a plus b must be 0. Therefore, a equals to minus b. Similarly, c minus b equals to 1, and therefore c equals to b plus 1. And finally, 4a minus c equals 4, and therefore c equals to 4a minus 4. Now plugging equation 1 into 2, we get c equals to minus a plus 1. And plugging this into equation 3, we get minus a plus 1 equals to 4a minus 4, which results in a equals to 1. Then b equals to minus 1, and c equals to 0. Therefore, the integral can now be written as 1 over x minus 1 minus x over x squared plus 4. Here, just a quick one to say that I post new videos every week, so if you would like to boost your mathematical skills for free, then be sure to hit the subscribe button below. Now, the integration of this first term is simply natural log of x minus 1. And for the second term, we can use the substitution, u equals to x squared plus 4. Therefore, du by dx is 2x, and du is equal to 2x dx. Plugging this into the integral, we get a half of du over u, which integrates out to a half of natural log of u, and substituting x back in, we get the following solution. Please also check out these step-by-step tutorials on partial fractions and integration. Thank you for watching.